Alright guys, so I'm Kaden, and today for my video I want to talk with you all about Faraday's law. So with Faraday's law, we're basically explaining how we can take a normal coil or a normal wire that is not attached to any power source and induce a current into that wire, induced EMF as we call it. So to start off, I want to just take a look here at the equation for Faraday's law and explain how we get that induced EMF. So E stands for the induced EMF, is equal to the negative number of turns in the wire. So what that means is number of loops. So for example, let's take these two wires and explain. This wire has one loop, if you can see that. So for negative N, we put -1. This wire right here has three turns or three loops, if you can see that. So for N, we would have a -3. Next in our equation is the change in magnetic flux, represented here by this. And that may be the most important part of this equation that we'll talk about in depth today. And then that is all divided by the change in time, and that's how we solve to get our induced EMF. So let's talk about magnetic flux briefly and what it is. So magnetic flux, we'll talk about with these two pictures, is the number of magnetic field lines passing through an object. So here we have two magnetic field lines. This one has 4, so this would have a greater magnetic flux. And like I said, that's the most important part of this equation that we're going to talk about. Represented here is the equation for magnetic flux. And we're going to talk about how we can change that magnetic flux to get an EMF. So first, B we have is the magnetic field. So that is times by area and times by the cosine of theta in order to get the magnetic field. So I wanted to talk about those three variables in this equation more in depth to talk about how we induce an EMF. So number one, let's talk about the changing the angle. So if we have our wire here, I'll try and get closer so you can see. If we have our wire in this position, let's say that our magnetic field lines or our magnetic field is pointed downwards. So if we have arrows going this way, right? So our coil is stationary in that magnetic field pointed downwards. The angle that it's referring to is the angle between those magnetic field lines and the normal coming off the wire. So the normal would look like this in this situation, right? So to change that, in this situation, there's no difference. If these are the field lines, I'll use a different marker, that'll be better. So let's say this is the magnetic field pointed downwards, and this was the normal of the wire. So if they're going the same direction, there's no angle. So in order to change this variable to get a change in magnetic flux, we can rotate this. So let's say our magnetic field's still going down, but the normal is pointed this way. So, sorry, I'll remove this because I only have two hands. So our magnetic field lines are still going down, but the normal force is pointed out this way. That is the angle that we're referring to. So if we change that angle by rotating our wire in the magnetic field, then we can get a change in the angle, which will then change our magnetic flux, and a change in magnetic flux leads to the induced EMF, or the induced current in our wire. Secondly, let's talk about how we can change the area. This one's a little more simple. Basically, if we have our wire, we can change it so that it's bigger or smaller of an area, so that less or more magnetic field lines can pass through it. So if we change the area, once again that changes the magnetic flux, and a change in magnetic flux leads us to have an induced EMF. Lastly, let's talk about changing the magnetic field. For this one, I'm going to want to get this. So let's say here represented is our magnet, okay? So we have our coil not attached to any power source and our magnet. So when the magnet is stationary, there's no induced EMF in the wire. We only see an induced EMF when there's movement or a change in the magnetic field. So in that moment where it's changing, where it's moving, we will see an induced EMF in our wire. But if it's stationary, no EMF. So let's put that into perspective here. So if we change the magnetic field, if we're changing B, this variable, that gives us a change in magnetic flux, therefore leading us to have an induced EMF in the wire. So that pretty much sums up everything that I wanted to talk about today with Faraday's law. Thanks for tuning in for my video, guys. Hope you enjoyed it and hope I explained it clearly. So thanks. Have a great day.